All right, so we're going to go ahead and take a look at our notes. So this is going to be at the top of page 3. And so this is going to be what happens if the number of different particles change. And so first, let's talk about our protons. So whenever we change our number of protons, we're actually going to be changing the identity of that element. So remember that our atomic number at the top of our symbol box is going to give us the number of protons. And so whenever we change our number of protons, we're changing the atomic number, and that causes us to change our number, or it causes us to change our element. And so if we're taking a look at the periodic table, if we're taking a look at carbon, carbon has an atomic number of 6. Now, if we were to add a proton to carbon, its atomic number would change to 7, which means that we have changed that element to nitrogen. And so changing our protons will change the element. Now, our electrons, whenever we change those, we're going to change the charge of our atom. And this is going to be what we call an ion. And so whenever we change our charge, we're either losing or gaining electrons. And then our neutrons, whenever we change those, we're going to be changing the mass of the element. And this is what we call an isotope. Now, different elements have different isotopes to them. Some elements only have 1 or 2 of the isotopes, while others, we have like 15 different varieties of isotopes. So they do come in a large range. All right, so next is going to be our ions. Ions are going to be atoms that have more or less electrons than a neutral atom. So a neutral atom is going to be one that has the same number of protons and same number of electrons. So an ion is going to be one that either loses or gains electrons. Now, what happens is that if it has a negative charge, it means that it has gained electrons. So remembering that electrons are negatively charged, whenever those get added to an atom, they're going to become more negative. So we're adding negativity to our atom. And then on the flip side of that, a positive charge means that it has lost electrons. So if an atom has a positive charge, it means that electrons have been taken away. And so a positive charge, those electrons are being lost, and so we are getting rid of negative electrons. So that causes an overall positive charge. All right, so we're going to go ahead and kind of take a look visually at what is happening with this. So we're going to draw a Bohr model of each oxygen ion in the chart. So we're going to take a look at oxygen with a -1 charge and an oxygen with a -2 charge. But first, let's go ahead and just take a look at our normal oxygen atom. So right here, I have oxygen. Its atomic number is 8. So it has 8 protons, 8 neutrons, and 8 electrons. So our protons and neutrons are in the center in our nucleus, and then our electrons are going to be on the outside. So let me go ahead, I'll draw those in here. So we have 8 electrons, so how this is going to play out is going to be that we're going to get 2 electrons on this first ring, and then we are going to get 6 electrons on this outer ring right here. So it is going to look kind of like this. So this is going to be a normal oxygen atom. Now, what happens is that whenever we have a -1 charge to it, what we're going to get is going to be that an electron from the outside is going to be put into our normal atom. And so this is going to be transferred over here. And so that addition of an electron causes the -1 charge to happen. All right. Go ahead and fill that back in. All right, now if we have a -2 charge for our oxygen atom, what this means is that we are going to have 2 electrons that are going to be inserted into our atom. So we're going to end up with like an electron right here and an electron right here. So what we end up with is 8 electrons on that outer ring. And so we have gained 2 electrons. All right, so our next kind of large topic that we're going to really get into is going to be something that we call electron configuration. All right, so electron configuration is going to be the arrangement of electrons in an atom. And what we really want to get from this is that because there are so many different elements, we want to make sure that we keep track of all of their electrons. Again, the electrons are going to be one of the most important parts of our atom because they are going to be the ones that actually perform chemistry. So electrons are going to orbit the nucleus of an atom at definite distances and in specific areas that we call orbitals or subshells. And these orbitals are going to have different shapes to them. So this is going to get more into kind of like the quantum model of the atom. Right, so our different orbital shapes that we have. Our S is going to be our sphere. So this is going to be the very basic subshell. And remember that atoms are 3-dimensional, so it is not just going to be a circle, but an actual sphere. So whenever really kind of looking at this, think about it more in a 3-dimensional idea. All right, and then our P subshell is going to be a dumbbell type of shape. Our D gets a little bit wonky. It is going to be kind of a clover leaf shape, or it can be a dumbbell with a donut around it. And then our last one is going to be our F, and those are typically going to look kind of like a flower. And so whenever kind of going through this, just make sure that you're thinking about them in 3-dimensional. All right, so for the periodic table, we are able to divide it up into these different subshells. And so what we get on the far left is going to be our S. In the middle, those transition metals are going to be our D block. To the very far right is going to be our P block. And then at the very bottom is going to be our F block. And so remembering these is going to be really important. All right, now, each orbital can only hold a limited number of electrons. So like our S orbital is only able to hold 2 electrons. Our P is able to hold 6, our D is able to hold 10, and our F is able to hold 14. So kind of looking at the reason for that. All right, let me go ahead and go back. All right, so if we take a look at this. So our S block. So our S block being right here. All right, the reason that I can only hold 2 electrons is because there's only really 2 blocks right here. So there's only 2 places those electrons can go. Now, if we take a look at our D block, so looking at here in the middle, if we count those, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our D block is able to hold 10 electrons. All right, our P block, looking over here, this can hold 6 electrons. And then our very last block, our F block down here, is able to hold 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so this is going to be the reason why those subshells can only have a limited number of electrons in them. All right, so how our electron configuration is going to look is that it's going to be a sequence of numbers and letters. So we'll have like our 1s2, 2s2, 2p6, and this specific sequence of numbers and letters will actually give us an element. So in this case, that top one is going to be for silver. And so how this kind of breaks down is that the number out front is going to be our energy level, or our rho number. So if we go back and take a look on our periodic table, we have our rho numbers that are right here. So we have row 1, row 2, row 3, 4, 5, 6, and 7. So those are going to be our different rows that we have. So our first number will be for our energy level, or our rho number. Our first letter is going to be our orbital shape. So that's going to be which block you are in. And then our superscript is going to be the number of electrons, or the number of squares. So how we're going to really read this is that we are going to read it like a book. And so whenever reading like a book, we're always going to start at the beginning. So we're always going to start at 1s. So we're going to start over here, and we're going to read left to right. And so once we get over here, it's basically like the end of a paragraph. And whenever we get to the end of a paragraph, we go on to the next one and read left to right. And we keep on doing this until we get to the element that we want. Now, this does get a little bit weird, especially when we get further down. And so things that to really kind of pay attention to is going to be when we enter our D block. So whenever we enter our D block, we're actually going to decrease our row number by 1. So we'll be in 4s, so this will be like our 4s1, 4s2, and then as soon as we enter that D block, we'll drop down to 3. All right, so let's go ahead, we'll take a look, and we're going to take a look at sulfur. All right, so our sulfur is going to be right here. So we're going to want to get all the way down there. But because we have to read the periodic table like a book, we always have to start at the beginning. So we're going to start right here. So we're starting at row 1. So starting at row 1, we're entering into our S block. So remember that to the far left is our S block, so we get our 1s. And our S block is able to hold 2 electrons. So we're going to get our 1s2. Now, we're now at the end of our paragraph. We move on to the next. So we're going to start now at row 2. So we are now at row 2. We are entering into our S block, and it is able to hold 2 electrons. So we get our 2s2. We're going to continue on reading this across the periodic table. All right, we are still in row 2, but we're going to be entering into our P block. So remember, to the very far right is our P block. So this is going to be our 2p, and it is able to hold 2, 3, 4, 5, 6 electrons. We're now to the end of that paragraph. We move on to the next. So moving on to the next, we are now in row 3. We are entering into our S block, and our S block is able to hold our 2 electrons. So we get our 3s2. We're going to continue on reading this all the way down. We are still in row 3, but we are going to be entering into our P block. And what we're going to do is that we're going to count the number of squares until it gets to our S. So this will be our 1, 2, 3, 4. So we're going to get our 3p4. And so this is going to be the electron configuration for sulfur. Now, along with this, I do highly suggest writing this out on paper. All right. The test and practice, a lot of the practice will be on paper. So getting the actual like handwritten and going forth with that will help you a lot. All right, so let's go ahead. Let's take a look at another example. All right, let's take a look at lithium. All right, so lithium is right here. So we want to get to it. But we can't skip, so we start at the beginning. So we start at row 1. We are entering into the S block. And this S block is able to hold 2 electrons. So we get 1s2. We're at the end of our paragraph. We start at our next one. We are now in row 2. We enter into the S block, and it only takes 1 electron to get to our lithium. So we get our 2s1. And that is going to be the electron configuration for lithium. All right, let's go ahead. Let's take a look at magnesium. All right, so our magnesium is going to be our Mg. So it is right here. Right, we can't skip. We always start at the beginning. So we start at row 1. We are in the S block. It's able to hold 2 electrons. We're at the end of our paragraph. We start the next one. So we are at row 2. We enter into that S block. It can hold 2 electrons. We keep on reading all the way over. We are still in row 2, but we're going to be entering into our P block. And our P block is able to hold our 6 electrons. We're now at the end of that paragraph. We move on to the next. We're now in row 3. We enter into the S block, and it takes 2 electrons to get to our magnesium. So we get our 3s2. And so our 1s2, 2s2, 2p6, 3s2 is going to be our electron configuration. All right, let's take a look at one more example. So this will be our arsenic. All right, so our arsenic is going to be right here. So this is going to be our furthest one down that we've done. Right, so as always, we start at the beginning. So we are in row 1. We enter into that S block. Our S block is able to hold our 2 electrons. All right, move on down. We are in row 2 now. We enter into our S block. It can hold 2 electrons. So we get our 2s2. Keep on moving all the way over. We are still in row 2. We enter into our P block. So our yellow area is our P block. It is able to hold our 6 electrons. Right? Move on down to our next row. We are now in row 3. We enter into that S block. It can hold our 2 electrons. Keep on reading all the way over. We are still in row 3, but we're going to be entering into our P block. And this P block is able to hold our 6 electrons. So we get our 3p6. Keep on reading. So we move on down to our next row. We are now in row 4. We enter into our S block, and it is able to hold our 2 electrons. Now, remember, this middle block, this blue section, is going to be our D block. And whenever we enter into our D block, we have to drop down a row number. So instead of it being 4D, it is going to be our 3D. So this right here is going to be our 3D. And our D block is able to hold 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is able to hold 10 electrons. So we get our 3D10. Now, we continue reading. We're about to enter into our P block. And whenever we enter or re-enter into our P block, we go back up to the original row number. So we're going to go back up to 4. We're entering into our P block. And this is able to hold 3 electrons. And that is going to be our electron configuration for arsenic. R1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. And that is all there is.